Hello everyone, we are starting a free open lecture in our Discord. All our lectures are held weekly, without interruptions. If you, the viewer, want to ask questions and get answers online, join our lectures. You can find the link to Discord in our Telegram channel. To find out the lecture times, join our Telegram channel. So conceptually, what is happening? We are creating a graph of possible transitions between lines. We check when they are compatible with each other. From this initial step, we build a complete graph accordingly, ensuring that all nodes and edges are properly connected and represented. Then, we go through the lines systematically and iterate over the profiles in a methodical manner. From the profile, we carefully iterate over all possible transitions, which essentially means examining the edges, and count the number of ways to transition to the next line in the next mask. This involves a detailed analysis of each potential path and its corresponding transition. Are there any questions about this idea or any part of the process that needs further clarification or explanation? Please feel free to ask, as understanding this concept is crucial for the next steps. Yes, let's do it. How do we even check if the profile is compatible? How do we restore the line? And what about this? We're going to do it now. This will continue now. Do you want to become a cool programmer? Subscribe to our Telegram channel. That's really just a matter of implementation. So, what do we have here? We have an array with a detailed profile of where we are coming from and where we are going next. There is a profile of the lower line where exactly we are going, meaning that this lower profile should be an auxiliary array. With its help, we will recolor profile B accordingly. A. Q. With the help of this Q, we will build our graph accordingly. Accordingly, the graph itself is an adjacency matrix, a computed function. So, we will have dp stored in two lines, meaning this is our previous line, and this one right here is our next line. And yes, these auxiliary variables represent the number of vertices that we've passed through already. As far as I remember, this thing right here, by the way, I don't quite remember what it actually does, but it might be related to visits, meaning whether we've already checked out this particular line or not. Let's see now. TFSP, and here we add the exact vertex number that we assigned exactly. So they see that we have almost nothing without it, okay? Essentially, what is happening here is that we iterate over the mask from where we come. We take the mask from the queue to where we are going and check if they are compatible with each other. This process involves several steps. First, we identify the starting point and the destination. Then, we carefully examine the mask to ensure it fits the criteria. If it does, we proceed to the next step. If not, we make necessary adjustments. This iterative process is crucial for ensuring compatibility and achieving the desired outcome. Without this meticulous approach, we would not be able to achieve our goals effectively. First, we convert the mask that was stored in the queue to a normal form. Next, we carefully and precisely record the bit representation of the transition mask into array B for the current mask temp. We also just convert it to a normal form. Then we check if the strings can be joined. If they can, there is only one way to do it, which is check through the join function. We won't open it for now. We still need to figure out the constructor. Next, we convert the profile into a mask, meaning we transform the mask. For this mask, we create a vertex and add it to the total count. We also add this vertex to the queue because later we will iterate over all possible masks for it. We also add an edge to the adjacency matrix, which shows where we came from and where we are going. So the queue stores where we come from and the mask iterates where we are going. Regarding what happens in the constructor, there are questions that we will address when discussing the transition function slowly. It's not very clear how we are essentially assembling the graph here. To elaborate further, converting to a normal form involves standardizing the data structure so that it can be easily manipulated and compared. This step is crucial because it ensures that the subsequent operations, such as joining strings, can be performed without any inconsistencies. The join function is a specialized method that checks the compatibility of the strings and ensures that they can be merged in a specific way. This function is highly optimized and is designed to handle various edge cases that might arise during the joining process. process. Moving on to the constructor, this is a fundamental part of the program that initializes the objects and sets up the initial state. Understanding the constructor is essential because it lays the groundwork for all the subsequent operations. When we convert the profile into a mask, we are essentially creating a binary representation that can be used for efficient processing. This mask is then used to create a vertex, which is a node in the graph. Adding this vertex to the total count helps in keeping track of the number of nodes in the graph. The queue is a data structure that helps in managing the vertices that need to be processed. By adding the vertex to the queue, we ensure that it will be processed in the correct order. The adjacency matrix is a representation of the graph that shows the connections between the vertices. Adding an edge to this matrix helps in visualizing the path from one vertex to another. The queue and the mask work together to manage the flow of the program, ensuring that all possible paths are explored. Finally, the transition function is a critical component that defines how the program moves from one state to another. Understanding this function is key to understanding the overall behavior of the program. The process of assembling the graph involves multiple steps and requires a deep understanding of the underlying algorithms. So are you asking about everything in general? Or is there something specific you would like to know more about in detail? No, everything is okay. Let's try to describe it in a more abstract and clear way. We have a queue, and in the queue, we store vertices for which we will iterate over the next vertices, and then check if they are compatible with each other. The queue is implemented on an array, and we use the tail to move from one vertex in the queue to another. That's how TFSP works. Next, we essentially enter the current element in the queue, iterate over the mask of the next line for it, and transform both into a normal form. Here, we transform the bit mask that we are iterating over, and here we take the current vertex from the queue and also transform it into a human-readable form. Essentially, we are basically trying to elaborate on the process in a more unambiguous manner. We keep vertices in the queue, and we go through the next vertices to check if they are suitable with each other. The queue is realized on an array, and we use the tail to transition from one vertex to another. That's how TFSP operates. Next, we fundamentally input the current element in the queue, go through the mask of the next line for it, and convert both into a normal form. Here, we convert the bit mask that we are iterating over, and here we take the current vertex from the queue and also convert it into an easily understandable form. And at this stage, it is indeed clear that this is what we are doing. The very essence of this while loop do we already have profiles stored? The queue contains the initial profile, which is set to zeros, and then we will add new ones. That is, we have the starting points from where we begin iterating, and then we proceed further. That is, they will be added in such an unusual and distinctive number of already traversed vertices, which is quite fascinating and intriguing. Therefore, essentially, adding the next element to the queue, further, after we have made the normal strings that can be compared with each other, we use the join function to check if they can be connected or not. If yes, then we transform the profile into this mask, which is a crucial and significant step. So we had some array B in our code that we were working on at that particular time.
By the way, we have successfully transformed it into the desired form in the join function, making it look nice and neat, and then we convert it into a bit mask. After that, we add the vertex to the queue and create an edge between two vertices. Are there any questions about how we create the vertex here and why we create the edge here? For now, let's consider it as magic happening slightly. When we add a new vertex to the queue, is there a possibility that we will revisit or examine this particular vertex again at a later point in the process? Yes, that is before this vertex was. That is, we are essentially considering two profiles, A and B, and we basically go from A to B. First, let's take our vertex U. Initially, it was equal to B, meaning we were trying to join where A is on top and B is below. Then, after we created this edge, we enter this vertex U, and now it will be some A will try to knock on other vertices, meaning that by iterating through the elements in the queue, we try to create directed edges from each of these vertices to the next vertices. This is how we do it. We take some vertex and try to go from it to others. This is how the graph will be built, and there we check if an edge can be made between these vertices. To elaborate, we start with a vertex and attempt to establish connections to other vertices. This process involves checking each possible edge to see if it can be created. By doing this iteratively, we ensure that the graph is constructed correctly. Want to become a cool programmer? If you want to excel in programming, understanding these concepts is crucial. It helps in solving complex problems and building efficient algorithms. So keep practicing and learning. Join our Telegram channel